In this video, we're going to see experimental results for ground fault and open fault detection using SSTDR in a small string of solar panels. Here we have our 5-panel system next to a ground cable that is a part of the building's lightning protection system. In order to be effective, this system has to be a true ground. We have a technician come in and manually induce open and ground faults into the system, which are then detected by our own SSTDR fault detection software. This software grabs data from the SSTDR device as it is taken, performs calculations, and then detects and localizes faults as they appear in real time. We've already seen one open fault be detected as it was induced, and here we're going to see a ground fault appear. When we touch this unshielded cable to the ground cable, we see that a ground fault is detected at a proper location. This location is a little bit further down the string than the open fault was because of the additional length added by the cable. As we remove the adapter used to add this cable to the system, we see that another open fault will appear at the same location as before. We also see a waveform underneath. This is a baseline subtraction and represents all differences from the expected waveform. We then move on to the next location in the string. We create an open fault, which appears in the diagram from the software in between the first two panels, as it should. As we add the adapter back into the circuit, the open fault disappears. We add a cable into the system as before. Once this cable is added, we start seeing a lot of false alarms. This is because the cable is slightly coiled when it's first added, and the SSTDR is sensitive to parasitic inductances. Once the cable is connected to ground, we see a ground fault detected and located in the proper place. When we go to remove this cable, it gets coiled again, and we see a couple false alarms appear. But once the cable is removed, these generally go away. The cable is being manipulated and stepped on, creating some more false alarms. Once the adapter is removed, an open fault is detected as expected. And when the connectors are reconnected, the open fault disappears. We then move on to the third location in our string. When an open fault is induced, we see it appear between the second and third panels in the diagram. We also see a baseline subtraction appear as before. The vertical blue line indicates that that is the position of the fault. We then add a cable, as before, and connect it to ground. Ground fault appears at the expected location in the diagram, as the system detects the fault. As we remove the cable, the fault disappears. These are results from a small string, and we hope to investigate larger strings in the future when we can have more safety measures in place. For now, thank you for your interest in our work and for watching this video.